The next topic I want to go over before really diving into this section is the distributive property and how to use it in the upcoming chapters. So it's going to be very, very crucial that we kind of nail this kind of knowledge before moving on. So formally, the distributive property says multiplying a term by a group of terms is the same as multiplying the term by each component of the group individually. And so that's very wordy. What that means visually with a picture is if I have a times b plus c, this is the multiplying a term, the term being a, by a group of terms, the group of terms being b plus c, is the same as equals multiplying the term by each component of the group individually. So this is the same as this. A times the group b plus c is the same as a times b plus a times c. In other words, if you were to do this, you would distribute a to each term in this group through multiplication, and you keep this addition sign. This just says a is now multiplied by b, and a is now multiplied by c as well. And so again, kind of saying it the same but backwards, you can also say that a times b plus a times c is the same as a times the group of b plus c. And so in our last video, we just saw factoring a little bit. This is the same thing. If you have a common term of a multiplied by both b plus c, you can factor a out of b and c and have them in a group. It's the same thing. This is multiplication using the distributive property, and this is factoring, or you call it reverse distribution if you want to think about it that way. But either way, these two things are reversible and both true. And so an example of that, we'll say use the distributive property to expand this term, 4x times x plus 2. And so 4x, I guess I'll rewrite it, 4x times x plus 2. This 4x, again, distributive property means we're going to distribute this to every term we have. And so 4x times x is 4x squared plus, this plus stays, 4x times 2 is 8x. And so this expanded becomes 4x squared plus 8x. Now, this and this are identical and equal, just represented differently. The next example we have is factor the greatest common factor, or GCF, out of this polynomial. And so this is kind of how we work back into the section's actual material using the knowledge we just learned. So we have 6y cubed minus 2y squared plus 8y. We're going to do our first step from last video, or the video before that, I'm not entirely sure. But our first step is to do a prime factorization. So 6 is just going to be 3 and 2. 2 is already prime, and 8 will be 4 and 2, 4 broken into 2 and 2. And so altogether, we have, we'll say 6 is equal to 3 times 2. However, we also have a y times y times y. 2 is just 2. However, this has a y times y as well. And 8 is 2 times 2 times 2 times a y. Okay, so this is going to be our prime factorization with our variables. Now, I should have wrote this too before that, 3, that's my fault, but take common factors between all three of them. We have a common factor of 2, so in our GCF, we're going to have a common factor of 2. And we have at least one common factor of y, so we're going to have a common factor of y. And we don't have any other common factors. This has 3 in y's, this has only 1 y, and this has only 2's, so nothing in common anymore. So our GCF is 2y. And so showing that, I want to just kind of give you a visual representation of using this property, taking this and turning it into this. And so if you had 6y, I'll write it out, 6y cubed divided by 2y will give you 6 divided by 2 is 3, and y cubed divided by y is y squared. You just take one of the y's away. 2y squared divided by 2y would just be y, and 8y divided by 2y would just be 4. And again, this kind of Variable cancellation and everything will be covered in later chapters, but it's kind of, you can recognize a pattern. If I have 3 divided by 1, you just take away 1. Again, 2 divided by 1, you take away 1. Same thing. Anyways, so this polynomial ends up looking like this. Since 2y is my GCF, I know I'm going to factor this out, and now I have whatever's left over. 3y squared minus, because this minus still stays, so minus y, what we had right here, and then plus 4. Oops. So this GCF, this polynomial, sorry, this paper's not working, right? Turns into this when you factor out a GCF. And just to show you that this is correct, I'm going to redistribute 2y back to all of these terms and show you get the same thing. So 2y times 3y squared is 6y cubed. 2y times y, and it's negative y, so 2y times y is 2y squared, so minus 2y squared, and 2y times 4 is 8y, so we have plus 8y. And so these two match, so we did factor out and redistribute correctly the GCF. And so that's how you use the distributive property. How to factor something out and show you factored it out is kind of leaving it outside a set of parentheses, and then how to distribute something back into a set of parentheses. So if you have any questions, leave them in the comments. And if you thought this was helpful, then you should like and subscribe.